So I hope in previous lectures I tried my level best to give you a fair idea about thinking of concept of vector, dimensions, degree of freedom, going beyond 3 dimensions, and so on and so forth. Now, keeping all the issues open, let us try to apply it in solving of linear equations. What is linear equation? Multiple variables, system of linear equations, issues of consistency, multiple solutions and single solution, number of equations more than number of unknowns, number of equations less than number of unknowns, number of equations equal to number of unknowns, all possible options we consider. Now we start with 2D. It's very simple, and but we will increase the complexity slowly so that you will find it not so easy but not quite difficult also. Let us move reasonably ahead. So in 2 dimensions, and we restrict ourselves to Cartesian coordinates. So what is a linear equation? The first module is system of linear equation. What is linear equation?
Equation which depends only on one variable.
No, that has nothing to do with linearity.
Degree one. Degree one.
The number of variables, how many it may be, 1, 2 or n, they exist in their first degree. That is, some constant into one variable plus some other constant into other variable plus some other constant into other variable. See, if we write it like this, so if we say that instead of x, y and z, we say x1, x2, x3 as variables and like that. So summation of ai, xi, I starting from 1, not 0, means it's convention. A0 we can also use, A1 we can use. 1 to n is equal to, it has to be equal to some constant, right? So that we can say as C, where these AIs and C are real constants. If we allow them to be complex, then it will change the entire perspective. So AIs and C are real constants. They can be either positive or negative. Is it right? This is a linear equation. We restrict to number of variables equal to 2, then we increase to 3 and then beyond. Right? So I hope that you understand each and everything what I uttered here. So in K, and instead of xi, where it is used to represent so that it can be 1, 2, 3, 4 like that, but sometimes it is better to use xyz. Either you can use x1, x2, x3, x like that, or xyz, because xyz gives us a feel in 3D. So if we go for a simple equation and we are in a 2-dimensional thing where z is not taken into consideration, or when we say z not taken into consideration, not correct. It is that z taken into consideration and z equal to 0 is a hidden equation. When I say that one equation between x and y represents me a line, and when I am in xy plane, z equal to 0 is a rather than hidden or assumed equation, right? So y equal to mx plus c, or you can also have ax plus by equal to c. Ax plus by equal to c, where a, b and c are real constants, is equation of a line, right? So what does it mean? A system of linear equation, we can, as long as we are in up to 3D, we try to plot it. So if x-axis horizontal, y-axis vertical, then this line can be plotted. It would be a straight line, right? So 1 means here the situation is now number of variables 2, number of equations 1, number of dimensions 2. We are in a plane. So we can either, listen very carefully, we can either say that I have one equation and I am in 2D, or instead of saying that I am in 2D, I can also say that this is a given equation. Means ax plus by ax plus by equal to c is along with z equal to 0 represents a line, because otherwise if I don't specify that and I say that x, y and z are 3 variables, then x plus by plus c will become a plane. Is it right? Is it clear? Okay. Now there is one equation. So I get what is the, so here I am in a 2D, number of variables 2, number of equations 1. So how many solutions are there? How many solutions are there? What do we mean by solution? Let us restrict to 3D for some time being. When I say solution, it is a set of points which satisfy the equation. Set of points which satisfy the equation. So what is the solution of ax plus by equal to c? There is a line. So there are infinite points which belong to that line. They satisfy the condition. Now if I put some values, let us say a equal to 1, b equal to -1 and c equal to 0, what does it represent? X equal to y. It represents x equal to y, right? So all those combinations for which x equal to y are the solutions of this equation. So 2 variables, 1 equation, we get infinite solutions. Is it right? Now if I have one more equation, that equation is, let us say, x plus y equal to 0. If I have one more equation, or let us take some simpler one. If I have one more equation, that is x equal to 3. That is x equal to 3. Obviously, this is always there. Z is not considered, or I am in xy plane for which z equal to 0. So now this second equation has got how many solutions? X equal to 3. How many solutions? Infinite solutions. So what are the points? 3 comma anything. 3 comma anything. So any y for which x is 3, so it is a line parallel to y axis at x equal to 3. So if these are my coordinate axes, this is x equal to 3 line, and this is x equal to y, right? So the first equation is satisfied by infinite points on this blue line. The second equation, x equal to 3, is satisfied by infinite points on yz line. Then, if both equations are to be simultaneously true, in that case what we must have? In that case, those are satisfied by only one point That is this one. Point 3 comma 3 is solution of this. Is it right? Is it okay? So this is a system of linear equations. Now suppose if I say that there is one more, so let first equation be as it is, and I will have second equation. Second equation is, this is first, this is second in earlier case. Now I cancel this and I will say that I will have one more equation. I will have one more equation, that is x equal to y plus 2. Why 2, 1, I take 1. X equal to y plus 1. What will happen? X equal to y plus 1. What kind of line it would be? Obviously straight line. It's a linear equation, straight line. What will be slope? Slope same, 45 degrees, but passing through at x equal to 0, y is equal to 1. Sorry, at x or at y equal to 0, x equal to 1. So this line would be so blue line is solution is containing, so blue line represents a set of points which satisfy equation 1, whereas green line gives me a set of points which satisfy this equation 3, I can say. Now I very clearly see that equation 1 and equation 3 cannot be simultaneously satisfied. Equation 1 and equation 3 cannot be simultaneously satisfied because these are inconsistent. Two inconsistent equations in 2 dimensions represent the parallel lines. Parallel lines. They are inconsistent. This is in case of 2D. Now, if we move to 3D, so we remove the condition of z equal to 0. The moment at which we remove the condition of z equal to 0, what I will get? I will get 3 variables. X, y and z. I will get 3 variables. Now, when I get 3 variables, let us talk about an equation with 3 variables. What one equation with 3 variables will represent? What one equation with 3 variables will represent? It will represent a plane. One equation with 3 variables will represent a plane. So if I say that last time itself you got confused and you could not even visualize the plane, but so if I have x plus y plus z equal to 1, what does it represent? It represents a plane. It represents a plane. So how many solutions are there for a plane? A plane consists of infinite points. So one equation, you can choose 2 variables and third will be given to you by the equation. So its solution is a plane, means it is having infinite solutions, right? So a system of linear equations in 3D where x, y and z variables exist, one equation will provide you infinite solutions. Number of variables 3, number of equations 1, infinite solutions. Now, if I have one more equation, what will happen? If I have one more equation, then what that will provide me? It would be another plane. It would be another plane. Right? Is it okay? One equation will be of another plane. So, what are the possibilities now? Means now, if it is, so if x plus y plus z equal to 5, what will it will represent? It represents another plane. And now by common sense, rather than visualizing, by common sense we find that both can't be simultaneously satisfied. Are you getting me? So they represent parallel planes. They represent parallel planes. If it is not a parallel plane, then they must intersect. Then they must intersect. So when they intersect, what will happen? When they intersect, we get a line. Suppose we have say x minus y plus z equal to this is another plane. So, a system of linear equations in 3 variable scenario, 2 equations which are consistent. If parallel planes, equations are non-consistent. If 2 equations are consistent, they will provide me a line. So, these 2 together will be, means 2 equations represent a line in 3 dimensions, right? So this will be a line, and how many solutions? Infinite solutions. In previous case, in 2D case, we had one line which is having infinite solutions, another line infinite solutions. So when 2 lines meet, they meet only in a point which is unique. Finite solutions. Means in the previous case, when z equal to 0 is assumed, one line x plus y, x equal to y, other line x equal to 3, each of them is having infinite solutions, but both are satisfied only by one solution. Now here, now what is the scenario? So I hope that your vision should be broadened. First equation represents one plane, which is having huge set of points, infinite set of points. Second equation represents another plane, which is a non-parallel plane, which also consists of infinite points. Then their intersection, the intersection set means a set of points which satisfies both equations is also an infinite set. बघा लक्षात येते का? सोपं आहे, अवघड नाही. In earlier case, in 2D scenario, a line was having infinite solutions, another line was having infinite solutions, but their intersection set was finite, only unique. Whereas now, their intersection is a line which is having infinite solutions again. Is it right? So, what I see here that the coefficients are odd. So, as coefficients are odd, I am finding what you are doing. You look here. coefficient being odd, I am finding it somewhat difficult to visualize. Rather than that, if I consider, I simplify the equation, z equal to 2. What is z equal to 2? Z equal to 2 is a plane parallel to xy plane at z equal to 2. Then I say y equal to 3. It is a plane parallel to xz plane at y equal to 3. So z equal to 2 and y equal to 3 is a line. This x, y equal to 3 and z equal to 2. So this is line. Are you getting me? So these two together is this line. Is this line. Is it okay? Right. So they represent line. Now, when two equations represent a line, how many solutions are there? Again infinite. This plane was carrying infinite points. This plane is carrying infinite points. So, both are simultaneously satisfied by this line, which also carries infinite points. Means again, even I have two equations in three variable case, still solution is infinite but lesser compared to one equation. म्हणजे ह्या प्लेन मधले बरेच पॉइंट्स आहेत की जे या लाईनवर नाही आहे, ह्या प्लेन मधले बरेच पॉइंट्स आहेत की जे ह्या लाईनवर नाही आहे, आणि दोन्ही ह्या लाईनवरचे पॉइंट्स जे आहेत ते दोन्ही प्लेन मध्ये आहेत, पण ह्या लाईनवर इन्फायनाइट पॉइंट्स आहेत. नाउ इफ आय ॲड वन मोर इक्वेशन, व्हॉट विल हॅपन? If I add one more equation, what will happen? Then we get a third plane. So if I add one more equation, I get a third plane. Then when I get a third plane, what should happen? When I get a third plane, what should happen? When I get a third plane, what are the possibilities? थर्ड, आता बघा विचार करा, आता थर्ड प्लेन कशा कशा स्वरूपाचं असू शकेल? थर्ड प्लेन कशा कशा स्वरूपात असू शकेल? It's a very significant question. What are the possibility? किती possibility असू शकतील? So two planes represent a line. Two planes represent a line. Now the third plane which I am going to introduce will be of what type? Anyone? What happened?
Three planes intersect with each other, but not a certain point.
आता आपण what I do, हे अजून मी थोडं सोपं घेतो. अजून हे ह्याच्यापेक्षा हे सोपं आहे, ह्याच्यापेक्षा सोपं घेतो. काय घेऊया? बेसिक प्लेन घेऊ आपण. पहिलं घेऊया, कुठलं सोपं घेणार? Z equal to 0 हे प्लेन घेतो. Z equal to 0. बरोबर? आता दुसरं कुठलं घेऊया? Y equal to 0. म्हणजे काय आलं? Z equal to 0 and Y equal to 0. हे काय झालं? X ऍक्सिस झाला. आपण त्या अँगल ते बऱ्याच गोष्टी अशा असतात की यात काही रॉकेट सायन्स नाही का काही नाही आहे, पण तू ते आपल्याला ती सवय नसते का फ्यू थिंग्स कॅन बी अचीव्ड बाय प्रॅक्टिस. सो Z equal to 0, Y equal to 0. हा X ऍक्सिस झाला. These two planes give me a line, that is, it is X axis. These together give you an X axis. आता अजून एक प्लेन घ्यायचंय मला. आता अजून एक प्लेन मी कुठल्या स्वरूपाचं घेऊ शकतो? एकदम सोपे तीन आता मला तीन बघा मी हिंट देतोय. हे तुम्हाला आलं बघा कसं आहे तसा खूप सोपाच, पण विचार करायला लागणार सब्जेक्ट आहे. आता तीन तुम्ही अशी उदाहरण द्या, तीन उदाहरणं की ती वेगवेगळ्या प्रकारची असली पाहिजे. हा एक्स ऍक्सिस झाला, एक एक्स लाईन आली. आता सो टू इक्वेशन म्हणजे जी पहिली दोन घेतली ती मी कन्सिस्टंट होती, म्हणजे एक लाईन मला मिळाली. सो एक्स ऍक्सिस इज द लाईन बिकॉज ऑफ फर्स्ट टू प्लेन्स. नाउ आय नीड अ थर्ड प्लेन and I say that there are three options in which third plane is likely. What are three options? What are three options? एकदम सोप्यात सोपा ऑप्शन. कुठला सोप्यात सोपा ऑप्शन? X equal to 0. सोप्यात सोपा ऑप्शन घेतो आपण. तो काय घेतला? X equal to 0. म्हणजे काय झालं? YZ plane. So they meet at origin, right? So the line means two planes have given you a line and another plane will give you a point. It is x equal to 0. किंवा x equal to 2 पण धरू शकेल, काही अडचण नाही. So if it is x equal to 0, it will cut here, this point. If x equal to 2, it will cut here. So if x equal to 0, what is solution? 0, 0, 0 is a point which is on x-axis as well as satisfies x equal to 0. And x equal to 2 असतं काय होईल? 2, 0, 0. It satisfies all three equations. Is it right? आणि दुसरं काय घेऊ शकतो मी? दुसरं नाही. आता नको. आता ते एक्स इक्वल टू पण नको. आता लक्षात आलं. अजून दोन टाइप्स मला निवड करायची. एक्स इक्वल टू ते घेतलं ना. X plus Z equal 5. What will happen? How that plane would be? ते काय कुठं क्रॉस होईल? आता Z equal to 3 काय होईल? Z equal to 3. Z equal to 3 काय होईल?
XY plane crossing Z equal to
मग सोल्युशन नो सोल्युशन. पहिल्या दोन प्लेन मुळे ही लाईन आहे एक्स ऍक्सिस आणि आता Z equal to 3 कुठलं प्लेन? ही लाईन आणि हे प्लेन. लक्षात का? सो द प्लेन इज सेड टू बी स्क्यू टू द लाईन. प्लेन पॅरलल म्हणत नाही लाईनला. प्लेन इज स्क्यू टू द लाईन. Right? If any line, a line and plane are skew when one line in the plane is parallel to the given line and all other lines are skewed to the given line. लक्षात आलं का? A line and plane which never meet. When I am having a plane and non-intersecting line, there exists a parallel line to non-intersecting line in the given plane, only one line. And all the lines are skew. म्हणजे ह्या प्लेन मध्ये ही एक लाईन पॅरलल असणार आणि बाकी सगळ्या कुठली लाईन घेतली तरी स्क्यू असणार. राईट? सो दिस Z equal to 3 it gives me instantly non-consistency because I find that here I say Z equal to 0, here I say Z equal to 3. So instantly obvious non-inconsistency is there. So case 1 consistent equation unique solution. Case 2 inconsistent equation, no solution. No solution. Now case 3, can anybody tell me case 3? One equation which is neither this nor this. Neither this nor this. Y equal to
minus 5 or
नाही मग ते त्याचं झालं ना. अगेन आता ह्याचं नको आहे. हिअर consistent unique solution means for with respect to x axis this equation provides me unique solution, this is another which provides me unique solution, whereas this no solution. Now consider one more case. Give me example of one more plane which will be neither this nor this. Kevin?
X plus y plus z equal to
X plus y plus z equal to 1. काय होईल त्यामध्ये? X, he said x plus y plus z equal to 1. What that plane would be, it would be difficult for you to visualize, but y equal to 0, z equal to 0. So it is okay. Now let us say he is given a good example, even though this is not the answer to the question I asked you. So sometimes, even though the answer is not correct, it gives a new lookout for thinking. आता ह्याने काय सांगितलंय x plus y plus z equal to 1 असं ना वेगळं सोल्युशन सांगितलंय. आता मी काय चर्चा काय चालली आपली, एक पहिला प्रकार कन्सिस्टंट इक्वेशन विथ सोल्युशन, दुसरा इनकन्सिस्टंट. ह्याच्यापेक्षा तिसरा एक आहे जो मी विचारलाय पण तू त्यांना वेगळं सांगितलंय. त्यांना जे सांगितलंय ते ह्या वरच्या बसतंय खालच्या बसतंय. x plus y plus z equal to 1 हे प्लेन कसं असेल हे माझ्या डोळ्यासमोर येत नाही. माझ्या डोळ्यासमोर येत नाही म्हणजे आता बऱ्याचदा उदाहरण सांगतो की तुम्ही जिमनॅस्ट आहे, समजा आता हे बोट आहे, लिसन अगदी शाळेत सगळं उदाहरण आहे. हा हे बोट आहे, मधलं बोट, लिसन लुक हिअर, हे मधलं बोट आहे, तर हे इथं जोडता येतं का? तर अशक्य नाही आहे, अशक्य नाही. परंतु प्रत्येकाला ते येत नाही. प्रॅक्टिस करा, म्हणजे खूपच तुमची जिमनॅस्टिक बॉडी असेल, नुसती बॉडी असले उपयोग नाही, ती प्रॅक्टिस करायला लागते, तर ते जुळतं. तसं आता तसं जे अवघड आहे तसं एक्स प्लस वाय प्लस झेड इक्वल टू 1 हे प्लेन डोळ्यासमोर येणं, हे प्लेन डोळ्यासमोर येणं इतकं सोपं नाही. ते कसं असेल, त्याची कशी दिशा असेल? आता झेड इक्वल टू 0, झेड इक्वल टू 0 म्हणजे काय? हे बोट एवढं घ्या, मी प्रत्येकाला जमतंय. झेड इक्वल टू 0 म्हणजे हे प्लेन डोळ्यासमोर येतं, वाय इक्वल टू 0 म्हणजे हे प्लेन डोळ्यासमोर येतं. तसं हे एक्स प्लस वाय प्लस झेड इक्वल टू हे असं प्लेन जातं, ते येत नाही डोळ्यासमोर. पण ते सगळं आता डोळ्यासमोर सगळं येत नाही, मग आता मला जमतच नाही, मग मी काय करू? तर काय सगळं डोळ्यासमोर यायची गरज नाही, काही गोष्टी तुम्ही अंदाजे सॉल्व्ह करू शकता. हे ह्यात बसेल की ह्यात बसेल? एक्स ऍक्सिस म्हणजे काय? Z0 Y0, टाका Z0 Y0, Z0 Y0 टाकले की एक्स काय आलं? 1 आलं. म्हणजे 1 0 0 हा पॉइंट हे जो सॅटिस्फाय करतो, म्हणजे हे ह्यात तर नक्कीच नाही. दिस डज नॉट बिलॉंग टू इनकन्सिस्टंट, इट इज लाईकली टू बिलॉंग देअर. पण त्यातच का वेगळं, त्याच्यापेक्षा वेगळं असं एक आहे. आता आम्ही तुम्हाला आता ठीक आहे, आपल्याला जरी भरपूर वेळ असता तर इन्फायनाईट नाही आहे, त्यामुळे आता विचार थांबून आपण मी तुम्हाला पुढचा हे देतो. झेड प्लस वाय इक्वल टू 0, हे एक प्लेन आहे. झेड प्लस वाय इक्वल टू 0, मग काय होईल? आता विचार करा, म्हणजे हे कशात बसतं? झेड प्लस वाय इक्वल टू 0 हे प्लेन व्हिज्युअलाइज करता येईल का तुम्हाला? झेड प्लस वाय इक्वल टू 0 हे प्लेन व्हिज्युअलाइज करता येईल का? नाही येणार, यायला पाहिजे. म्हणजे हे आता कसं आहे, एवढं म्हणजे झेड इक्वल टू 0 एवढं होतं, एक्स प्लस वाय इतपत टेकवायचं होतं, आता इतपत टेकवायचं नाही, इथनं थोडंसं मागं आणायचं आहे, म्हणजे टप्प्यातलं आहे. झेड प्लस वाय इक्वल टू 0 कसं व्हिज्युअलाइज करता येईल? झेड प्लस वाय इक्वल टू 0, आता त्यात सुद्धा व्हिज्युअलायझेशन करताना सुद्धा मी त्यात किती एक्सपर्ट आहे याच्यावर अवलंबून आहे. काही जण पटकन करतात, पण काही जण तेवढे ज्याला आपण शार्प लर्नर्स नाही आहे, थोडा विचार करायला लागतो. पण त्याला आपण मांडणी वेगळी करायची. झेड प्लस वाय इक्वल टू 0 लगेच लक्षात येत नाही, म्हणून काय करायचं? झेड इक्वल टू मायनस वाय, झेड इक्वल टू मायनस वाय. मग झेड इक्वल टू मायनस वाय म्हटल्यानंतर काय करायचं? आधी वाय पकडायचा काहीतरी. समजा हा एक वाय घेतला, हा वाय घेतला प्लस, तर झेड काय आला त्याला? मायनस. म्हणजे आता मायनस पलीकडे जाते, म्हणून काय करूया? वाय हा पकडूया. वाय मला दिसतो इथं, झेड तिकडे जाते म्हणून वाय -1 घेतला. वाय -1 घेतल्यानंतर काय ना झेड +1, म्हणजे कुठे राहणार इथे, बरोबर. आणि एक्स काही चालतो, एक्स काही चालेल, वाय मायनस तितका झेड प्लस, वाय जितका मायनस तितका झेड प्लस, असं ते कसं प्लेन होईल? पासिंग थ्रू एक्स ऍक्सिस, म्हणजे कसा? पासिंग थ्रू एक्स म्हणजे असं असेल, असं नाही. इथं काय होतंय? वाय आणि झेड, हे वाय इक्वल टू झेड आहे, लक्षात आलं का? हे प्लेन, हे वाय इक्वल टू झेड प्लेन आहे. कसं प्लेन असेल ते? असं प्लेन, लक्षात आलं का? हे प्लेन म्हणजे कसं? झेड वाढतोय, वाय ला प्लेन मिळतोय, आणि मागं असं, लक्षात आलं का? दिस प्लेन, सो दिस प्लेन विल पास थ्रू एक्स ऍक्सिस. मग आता झेड प्लस वाय इक्वल टू 0 and x-axis, what will happen? Are they consistent? Yes. But do they provide unique solution? No. Infinite solutions. म्हणजे काय? A line, when in 3D, when I have one line and one plane, there are three possibilities. Number one, the line belongs to the plane. So, z plus y equal to 0 and x-axis, any axis allowed. So, z plus x-axis belongs to plane z plus y equal to 0. So, a line and a plane, the line may belong to the plane, it is consistent with infinite solutions. म्हणजे काय? हे इक्वेशन एक आहे, हे इक्वेशन एक आहे, दोन इक्वेशन झाली आणि हे तिसरं इक्वेशन जे आहे त्यात मी काय केलंय? आता पुढचं ह्याला म्हणतो लिनियर कॉम्बिनेशन. पहिलं होतं z equal to 0, दुसरं होतं y. दुसरं होतं y equal to 0. आता तिसरं इक्वेशन काय केलंय? तिसरं नवीन इक्वेशन नाही आहे, या दोघांचीच ऍडिशन आहे. इट्स अ लिनियर कॉम्बिनेशन. सो z प्लस किंवा आधी इथे आपण सिक्वेन्स चुकवायला नको. y plus z equal to 0. So this is a linear combination of these two equations. So it's not a third equation. So here basically equations are two only. It's a situation where there are three variables and only two equations, because by having a linear combination of two equations I can construct any equation. This is not an independent equation. So number of, in 3D, when number of equations are less than 3, it provides me infinite solutions. So here two equations. This is not an equation at all. So I need to have three independent equations. In a system of three variables, I need three independent equations, and three independent equations will result either into a unique solution or inconsistency. म्हणजे two equations give me a line, then third equation, if it is a linear combination of first two, that is a plane which will belong, that will be a plane in which the line will belong. If that equation is not a linear combination, then that plane may either intersect the line, or that plane may be a skew plane. If it is skew plane, it is inconsistent. If it intersects in one point, that is the unique solution. Is it clear? Okay. So today is enough. We will continue next time. And absent students should note that there will be very severe disciplinary action leading to defaulter. They should not take it casually.